All right, guys. So I'm sorry I can't be there with you today. I am home with my Sam. He has the flu, and I'm hoping that nobody else in the house gets it. So if you will just look at this, this is just a funny little comic, so you can read it and get a giggle if you need one. Um, we are going to go to the next page. And just remember when we're talking about one-step equations, we did the activity on the computer, right, with the balance scale, and it was all about giving and taking. So if we did something to this side, we had to do the same thing to this side so that it would stay balanced, okay? So we're going to look at two problems, and then you guys are going to be on your own. Today you're going to try to get away from using the model. But remember, it's always there. So the algebra tiles are there. You can get them out. You can use them. You can draw them if you need to. But also now we want to get into where we're really using that algebra to solve these, okay? And if you'll remember, yesterday Ms. Rivera should have showed you the new poster that we put in the room with our integer operation rules. So it's got your suggestions up there. We're going to be working a lot with these negative numbers. And so you definitely want to make sure that you are that you're ready to use these. Okay. Okay, so here we go. This first one, it says to solve the following equation for x and represent your answer on a number line. Okay. When we're doing this, and I'm gonna model what this looks like with um, algebra tiles, right? So we have x, and we have x plus 5. Okay, and then we know that x plus 5 equals negative 17. So over here I use squares. You might want to use just circles, maybe. It's up to you. They're easier to draw. They take less time. Um, so if you really need that model, and by coloring these in, right, that should be 16 and there's 17. By coloring these in, you show that they're negative. By not coloring them in, you show that they're positive. Okay, so I have x plus 5 equals negative 17. So the first thing that I want to do is I want to get rid of these 5, right? Because I want x by itself. I want to get this little x all alone. So in order to do that, these are positive. In order to take them away, I need 0 pairs, right? So I'm going to add those 0 pairs. So if you think about it, you're adding negative 5, right? And by doing that, they're coming off, okay? So over here, you're going to think about it the same way. You're going to add, what did we do on this side? Well, we added 5 negatives, right? So we're going to do the same thing over here. We're going to add 5 more negatives, okay? And so now our answer got more negative, okay? Now, what did that look like mathematically? Well, I added 5 negatives, okay? And I'm going to do the same thing over here. I'm going to add 5 negatives. Now, remember those parentheses? They're just there to hold that negative sign. So by adding positive 5 plus a negative 5, right away those become 0, right? As mathematicians, we don't have to write the 0. We can just assume that 5 plus a negative 5 is 0. So we say that x is going to equal whatever this is over here. Well, it's negative 17 plus negative 5. If you use several things here, you can use your model. And if you look over here, did I add any positives? There's no 0 pairs. So really, I had 17, and I added 5 more negatives. So I have 18, 19, 20, 21, 22. And over here, if I look at negative 17 plus negative 5, I can just do 17 plus 5, which is going to give me 22. But because they're both negative, it's going to keep the negative sign. So I know that this is going to be x equals negative 22. Okay. And then down here on the number line, you can see that it gave you your negative spaces already. This one's counting by 2's. When we know that something is equal, we know we're going to put in a closed dot, okay? There's no arrows on this one because it's just equal to. It's not, we're not doing an inequality where we're using the symbols, okay? We just know that it's equal to, so there's just going to be a closed dot over the number that x equals, okay? So that's, there's lots of ways that you can solve these problems. So even if you get to it and you're like confused as to what to do, go back to your picture. And if the picture's hard for you to do, get out the tiles. Build with the tiles if you need them, okay? All right, so now let's look at this next problem. And this one looks like it says 15 equals m minus 6. And no matter what side the variable's on, right? On this last problem, where was the variable? It was over here. X was on this side of the equal sign. But over here, we don't even have x, we have m, and it's on the other side of the equal sign. Doesn't matter. It doesn't matter because we can put it wherever. It doesn't matter. We're just solving for this variable, right? We just want to get it by itself. So over here, if I was going to draw a model, I have 15 positives. So I'm going to make 15 positives. And I know that that's going to equal, this sign is my equal sign, and I'm going to just draw my x. And it equals negative 6. X minus 6, sorry. Okay, and so there's my negative 6. Okay, and so when I look at this, I need to get x by itself. Well, the only way I can do that to get rid of these negatives is that I have to add in 6 positives, okay? So if I add 6 positives over here, right, what do we know happens? These go away, but I have to add 6 positives over here, okay, because I did, remember back to the balance scale, it's got to be the same. So now I have x is on its own, because these are gone, and now I know that x is equal to 15 plus 6, which is 16, 17, 18, 19, 20, 21. So now I know that this is 21, and this is x, or m, or whatever it was. So that's picture. What did I do? Well, guys, I added 6 positives. Well, negative 6 plus positive 6, remember, that's understood that we're going to get 0. Your m stays here because we want it by itself. And if I added 6 on this side, I have to add 6 on this side. So 15 plus 6 is going to be 21. And 21 equals n. Now, where do I put that on my number line? Close dot, right over 21, and that is how that works. Okay. Okay. So I think that's it. There's nothing left on this slideshow. So hopefully you will do great on your practice work that you're about to do. And there are several problems. Ms. Gresser, our substitute today, has the answer key. So if you want to do 2 problems and then go check to make sure that your work is right, and then get going on the rest of that practice problems. Okay, hope you guys have a super day, and I will see you tomorrow.